physicist. And one of the questions I get asked all the time is, should I go to grad school for physics or astronomy? And the answer is, in short, probably not. And in this video, we're going to talk a little bit about why I say probably not. Now, I want to note this entire thing is aimed at people who are getting a bachelor's degree in physics, astronomy, or a closely related field. This is not aimed at people who are pursuing some other kind of study and thinking about whether they want to transition into physics. If you are not in one of those fields, your path to physics or astronomy grad school is going to be even harder, and it's probably going to involve you needing to take the sort of core physics classes like classical mechanics, electromagnetism, statistical mechanics, and quantum mechanics. Without those classes, you're basically just not going to be able to get into grad school, nor will you be able to do the requirements. But I tell people that my answer to should you go to physics grad school is probably not, and they're often kind of struck by that. They're sort of surprised, and they would say, why wouldn't I go to physics grad school? I love physics. So let's take a second and talk about a couple good reasons to go to grad school and a couple bad reasons to go to grad school. These are three of the most common bad reasons I hear why people want to go to grad school in physics and astronomy. I like my classes, I don't know what else to do, and I want to be a professor, although there's an asterisk by that one, and we'll come back to it. I hear from students all the time, I really like my classes, I want to do more classes, there's more physics I haven't learned yet, shouldn't I go to grad school to do that? And that seems like solid logic on the surface, but it demonstrates a fundamental misunderstanding of what happens in physics and astronomy grad school, which is a little bit taking classes and a lot doing research. So this is in the US and Canada, where you do take graduate classes. In Europe, Australia, other parts of the world, you don't take any classes at all once you finish your bachelor's degree. But if you're in an American or Canadian program, you will start out by taking a couple years of classes. And the goal of that is really just going to be to get through it. This is not really a venue where you're going to want to spend time on your classes where that's going to be your focus. You will spend time on them because they're really hard, but that's not going to be the thing that you're excited about. And once you finish those classes after a year or two, you're going to spend the rest of your time in grad school, which is on average about 6 years, doing research. So it's primarily not something where you're going to be doing more advanced physics classes. It's primarily something where you're going to be doing physics research. The second bad reason I often hear is, I don't know what else to do. Now, there's a good reason trapped inside of this bad reason. If you've evaluated a bunch of different career options and decided that the one you want to do most is physics, or there's nothing else calling to you, then that can be a good reason. But often people say this and they mean, I haven't really thought about what else I can do after my bachelor's degree, and so I assume the thing to do is to study more physics. I've been in school all my life. This is since I was like 5 years old, I've been in school. So of course, when I don't know what to do next, I should do more school. And again, that's going to get you into trouble, because even if you're really good at undergrad physics, like we just said, graduate physics is not taking more classes, it's a different set of skills. And if you just sort of flip-flop your way into grad school, you may not be ideally equipped for what grad school actually is. There's also the financial element to consider. This is not the fun part of talking about grad school, but I think it's really important and we do need to talk about it. And that's the money. It stinks. Often people are very excited to find out that in a PhD program in physics, they'll get their grad school paid for. They won't pay tuition and they'll receive a stipend. And that's great. It's certainly better than paying student loans, but I think it has to be considered that this is not exactly the lap of luxury. This is data from the American Institute of Physics about the median stipends and the types of support given to new physics bachelor's students who've started a PhD program. The top line is physics and astronomy, the middle line is engineering, and the bottom is other types of grad school. The purple is people who are doing teaching assistant jobs, which you see that's about 50% of physics and astronomy grad school, and about 15% for engineering. The blue is research assistants, where you're just focusing on your research or someone else's. And the yellow is fellowships or scholarships. The green is people who are paying for their degrees themselves, which you should never ever do. But I want you to focus in on those numbers. As a median, so more or less on average, you're going to be getting about $25,000 to $30,000 a year as a physics PhD student. This is certainly, again, better than zero, but it's not a great wage. It's not going to be something where you're going to be able to live very well in a lot of places, and importantly, it's also not something where you're going to be able to build savings. And you want to think about things like savings and your future, because this is going to be most of your 20s if you decide to get a PhD in physics. The average time to completion is about 6 years. So if you graduate college when you're 22, you'll be about 28 when you finish your PhD. And it's worth considering that's now nearly a decade of your life that you haven't been investing, you haven't been saving, you haven't been thinking about retirement or houses or any of that kind of thing. And you might be thinking, well, that's grad school, but that's just a few years of my life, and then I move on to bigger and better things, right? Well, sort of. So this is, again from the AIP, the starting salaries for new physics doctorates. And you'll notice people that go in the private sector start out after their PhD a little over $100,000, maybe $125,000 on average. People who get into a permanent job at a college start out at about $75,000. People who end up in postdocs end up between basically $50,000 and $75,000. And some people end up in other temporary positions at colleges, and those are averaging a little under $50,000. So these are decent salaries, but none of them are going to blow your doors off and make you fabulously wealthy, except perhaps those private sector, especially if you follow the edge of the box and whisker plot out here. We also have to consider what percentage of people are actually getting which number. So let's look at that. Well, so about 50% of people are here in this blue category doing postdocs. So they're averaging between $50,000 and $75,000 per year. And about 40% of people are up here in the green, either at a college or more probably in the private sector. If you look further into the data, almost everyone in the potentially permanent positions is in the private sector. They've gone into industry, which is great. I know very few people who've regretted that. And then, there's about 10% more who are either unemployed or in another temporary position. Now, don't let that 5% unemployed number scare you. That's pretty consistent with typical unemployment for the population. Now, most people's goal is obviously not to be in a temporary postdoc position, and indeed you can't stay in those roles forever. Those usually end up capped around 5 or 6 years. So what are the odds if you start out as a postdoc, you'll end up a professor? This gets into point 3. I want to go to grad school because I want to be a physics professor. Well, let's take a look at that. Every year, this is how many, on average, physics PhDs are granted. If you add up all those columns, I got 1,880. So about 1,900 people get a physics PhD every year. And this is on average how many new physics professor jobs there are. 556. Now, we can all do math here. We're talking about physics grad school, that goes without saying. That means that there are several times more new PhDs every year than there are new faculty jobs. And then you have to consider that these new hires also have to encompass anyone changing faculty jobs. And if you do the math out, it ends up being about 1 in 10 people who get a physics PhD will go on to be a professor. Now, a lot of people who get physics PhDs don't want to be professors for a whole bunch of reasons, and that's great. But if your primary reason for getting a PhD is that you want to be a physics professor, you should have that 1 in 10 number in the back of your mind and understand that this is not a guarantee. So if the only reason you would want to do it is because you want to be faculty, probably shouldn't do it, because no one can guarantee you a faculty job at the end of your PhD, or even after a couple of postdocs. And while I'm in negative Nelly mode, it would be irresponsible not to talk about the opportunity cost of your time. One thing people don't often think about when they're starting their PhD is that you're going to be living in a place for 6 years. And that place may or may not be somewhere you would ever choose. It may be far from family, it may be far from friends. If you have a relationship, that can be very complicated. And you also may not feel like you can put down roots there fully because you're there for 6 years, and then if you're planning on chasing the academic path, you plan to move again. Then if you're a postdoc, it's even worse. You're there for 2 or 3 years, and so you can't really build a lot of deep connections. You can't necessarily find a relationship or a good group of friends because you're going to be moving somewhere else in a couple of years. And although that can be kind of fun when you're just graduating college, many people find that it starts to wear on them as they get closer to their 30s. So it's something you should weigh in the balance when you're thinking about whether you should go to grad school. Now, having got that negativity out of the way, here's a couple good reasons to go to grad school. One, and this is the main good reason to go to grad school, I like to do physics research. I am interested in doing scholarship that will push forward physics or astronomy, and it's not something I can learn in the classroom. Another good reason for grad school is that you're not going to a physics PhD program. I know many people who've had a very successful experience going for like a master's in electrical engineering or a master's in material science or an additional degree in computer science, something intended to launch them from a more esoteric physics degree into a more definite career path. That's often a good reason to go to grad school.
although it's usually a kind of a different world. And the third good reason for grad school can be, I want to be a professor. Because although all of those caveats I just said apply, and your odds aren't that great, it is true that if what you really want to do is to be faculty, to do research, or also to teach physics at the college level, if either of those are your goal, then this is something where you're going to need to have a physics PhD.
You know, the thing about the physics PhD is that it fundamentally is a research degree, not a taught degree or a classroom degree. And that means that if what you want to do is more physics research or astronomy research, then it's a great fit for you. And for a lot of people, even if they never continue in physics and astronomy after their degree, that 5 or 6 years of doing physics research or astronomy research is really, really exciting to them. And as we saw, you know, the average physics PhD 1 year out of graduation has a 5% unemployment rate, which is competitive with just the general population's unemployment rate. So it's unlikely to make you less likely to get a job. And statistically, very few physics PhDs end up as baristas. So if your primary goal is to do more research to push forward the bounds of what we know about physics, then this could be a great. Now I know this video is kind of tipped towards the negative side. Don't go to grad school. And allow me to say what I usually say to people when they ask me. I say, if there's something else you want to try, if you either want to be a software engineer or a graduate student, you want to be a high school teacher or a graduate student, you want to do full-time outreach or be a graduate student, try the other thing first. If the thing you want to be that isn't grad school is something that's basically technical, it'll use your physics skills to some degree, even if that means in an educational context, it's very likely you'll be able to come back to grad school in a couple years and find that it's still there, your credentials are still good, you can still go. If you've tried it and you realize, I want to be a physicist full time, I want to do research, that's what I'm excited about. But getting a physics PhD is difficult. And you know, I've done it, but I can tell you, most of physics is not so scary, but getting a doctorate actually is pretty scary. And you want to be 100% sure that that's what you want when you take it on.